Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thanks to all of the committee and all of the participants who give me a chance and time for presenting my article. Okay, let me introduce myself. My name is Aulia Afifah. I am from Chemistry Education Department, UPI Bandung. And this is my article. The title is Integrating Molecular Basis of Sustainability to Teaching Learning Sequence of Fire Retardant Bamboo as Sustainable Material, Results from Qualitative Content Analysis. Okay, first I will explain about the research background. As we know, bamboo is a highly adaptive plant which easily adapts to different biodiversity, climate, and soil conditions. Bamboo has perennial properties and a faster growth rate, especially after the first few years. Bamboo has been widely used to make household and construction goods, and it has been widely recognized as a sustainable material for several reasons, including bamboo can be easily cultivated and harvested in a relatively short time and can be reused, which is between 3 until 5 years. But although bamboo has the potential to be a source of sustainable material, it still has some serious weakness. One of it is the high risk of flammability, which limits its application. Bamboo also has electrostatic properties, which can cause an explosion risk if used for chemical storage rooms that are flammable. Then sustainability is based on the molecular basis of sustainability, a term that emphasizes that many environmental problems stemming from molecular consideration must be overcome with solutions that highlight the molecular dimension as well. So, the weakness in bamboo can be overcome at the molecular level through the engineering of fire retardant bamboo using ionic liquids. This molecular engineering can be used to integrate the principle of molecular basis of sustainability in teaching and learning. Okay, next is research method. The method used in this research is qualitative content analysis or QCA from Meyering with the type of literature analysis. This method have 4 stages and they are material collection, and next is descriptive analysis, next is category selection, and the last step is material evaluation. The first step is material collection. At this stage, the sources of the content that will be analyzed are collected. The sources include textbooks, monograph, article review, and article research. Okay, the next step is descriptive analysis. In this step, we are describing the analyzed content from the sources that have been collected. Next is category selection. In this stage, we are structuring the result of the content analysis. At this stage, there are activities to incorporate pedagogical and didactical aspects into the content that has been analyzed. The concepts that have been analyzed are also categorized based on science, technology, and engineering, and also grouped by system. And the last stage is material evaluation. In this stage, we review the material from the beginning till the end and describe it into a structured concept map and teaching learning sequence. Okay, the next is result and discussion. This is the result of the first stage, and it is material collection. In this stage, we collect the literature from the various sources. The sources will be used as the references in the preparation of the content analysis. The result of the literature collection stage are presented in this following table. There are 13 sources that I use for content analysis, but in this slide, I only show 4 sources as an example. Okay, this is the first source. The title is Bamboo, the Multipurpose Plant. The type is a textbooks. The author is Alkin Labi, Anna Nuvenin, and Aquada. And the year is 2017. and the code is A. The code here is used for the citation in the next stage. Okay, next is the result of descriptive analysis stage. At this stage, the author analyzes the sources that are used as references and then describe the content. The content in this table are some of the scientists' conception related to the topic of bamboo fire retardant using ionic liquids that have been analyzed, including the definition of bamboo, weakness of bamboo, and properties of ionic liquid. In addition, scientists' conception of bamboo properties, bamboo composition, and ionic liquid as fire retardant agent in bamboo have also been analyzed from the literature, but they are not shown. Okay, the next is the result of the category selection stage and material evaluation stage. In this stage, the result of the content analysis are grouped into the categories of science, technology, and engineering. The content that are included in the science category include the definition of bamboo, the component of bamboo, and the properties of bamboo, uh, which are marked with a yellow background. And then the content that is included into the technology category is the application of bamboo, which is marked with the red background. And then the content that are included in the engineering category that are content regarding ionic liquids, which include the properties of ionic liquids, component of ionic liquids, and the application of the ionic liquids on bamboo fire retardant, which are marked with the blue background. And then the content categorization is also grouped by the system. Bamboo content is categorized into core system, and then bamboo application are included in the desired use subsystem, and then the characteristic of bamboo is included in the subsystem of properties, and more specifically for the nature of bamboo is a subsystem of the sustainability aspect. And then the weakness of bamboo is included in the unwanted subsystem, which will be a bridge to the ionic liquid content, which is categorized as the solution subsystem. And then the properties of ionic liquids are included into the subsystem of properties, and the application of the ionic liquids on bamboo fire retardant is included in the subsystem of the production process. The concepts obtained from the result of the content analysis are mapped in the form of the concept maps and teaching learning sequences as shown in this figure. Each stage in the concept map and the teaching learning sequences is connected with the question that will show the relationship between one stage with another stage. Okay, the last is conclusion. After I explain my article, we can conclude that this research produced concept maps, teaching learning sequence, and clarified chemistry concept. Concept maps and TLS can describe the relationship between one concept and another, so that it will show a causal relationship to the problems and the solution offered didactically and pedagogically. The result of the research can be used as a basis for the development of teaching materials and didactic designs. Okay, maybe that's all from me. Thank you for your attention and apologize if I made many mistakes. Wassalamualaikum warahmatullahi wabarakatuh.